Welcome to Automated Visual Software Analytics. This part is about software maps. We will describe principles of software maps, outline information sources, and explain information mapping strategies. Let's start with an example of a software map. Here you see this example. It's a software map of the Android software system. As you can see, it's a 2.5-dimensional tree map underlying this concept of the software map. In this example, we have mapped the number of lines of code onto the ground size. The level of statement nesting, the NL metric, is mapped on the color, and the McCabe complexity is mapped on the height of the cuboids used in this software map. This specific combination, that is combining information about the nesting level with the McCabe complexity, for example, helps to identify and to monitor complexity hotspots in a software system. That is, a software map is a 2.5-dimensional tree map that combines certain software metrics or other information for a given theme. In this case, the theme is complexity hotspots. As we can see, there's also an explanation. For example, when the user clicks on this cuboid, then the information tells how these metrics have changed, how these measures have changed between the current and the last revision of the software system. Now let's explore a little bit more what are software maps and why have they been developed. This is a statement from an article about monitoring code quality and development activity by software map, and it's explained that a software map represents an adaptive hierarchical representation of software implementation artifacts, such as source code files, being organized in a modular hierarchy. The maps, the software maps, can express and combine information about software development, software quality, and system dynamics. They can systematically be specified, automatically generated, and organized by templates. And it's also stated the ultimate goal behind software maps within software analytics. The maps aim at supporting decision-making processes. So we see the most fundamental property. It's an adaptive hierarchical representation. It expresses and combines information about different aspects of software development. It can be systematically be specified and automatically generated, and it can be organized by templates. Though these are the fundamental properties of software maps. Now let's go on, and we would like to have a formal definition. Here it is. A software map defines a visual mapping of a hierarchy of software artifacts and related information to a 2.5-dimensional tree map. Yeah, there's related information mentioned. What does this practically mean? Related information can be information about the source code, the software quality, software dynamics and tests, for example, test coverage, software evolution, development activities, number of check-ins, number of engineers involved, etc. And in general, any information about the software development process. This is what software maps are about. They visualize and map information from different origins, from different sources of software engineering projects onto a unique and combined visual representation, a 2.5-dimensional tree map. Yeah, let's have a look at the general way information sources are used and Which are these sources? In this depiction, you see different software system artifacts, for example, the source code or code modifications. Typically, this is stored in, for example, a version control system, whereas data about execution or tests or even bug are stored in similar repositories, software repositories, for example, bug repositories or bug tracking systems. There are many more software databases, software-related databases, or any kind of repositories typically used in large software projects. However, these sources coexist but are not necessarily combined or interlinked. And this is one of the true and basic added values software analytics provides. It helps to link, to gather, and to even fusion information from different origins into a common software analysis database. So this is up to software analytics to form such a database, to extract information in an appropriate way, in a fast way, parsing information, requesting information, maybe even in real time, and then to do analysis and data mining tasks, and then the results of this analysis are given to the visualization stage here. This is the stage where visualization technology comes in, and for example, we can use different kinds of software maps, for example, a developer-related map or a quality-related map or any other kind of visualization technique. In this case, however, we will focus on software maps and how they are composed. Of course, these visualization means can be used by different stakeholders of software engineering projects, for example, developers, testers, system architects, or even managers. Yes, this is the overall workflow, and software maps are key visualization tools in this part when analytics results have to be mapped, has to be interactively provided to different stakeholders. The software map distinguishes between two categories of map data. It's primary map data and secondary map data. Primary map data generally has or includes 3 information dimensions on which it can be mapped. That means we have 3 information dimensions that can be used as primary visual variables of software maps. These 3 primary visual variables are ground base size, the color used for representing a cuboid, and the height. Like in the case of 2.5-dimensional tree maps, these are 3 principal visual variables or primary visual variables. There are secondary visual variables, for example, the texture that can be applied to side faces or top faces of the cuboids, for example, providing different hatching or different patterns to express certain additional information. And we can, of course, also change the cuboid's geometry by shape variations, rounded corners, conical shapes, like depicted here, where certain cuboids, especially those that are generalized, that is, they consist of further, more detailed cuboids, but they are generalized in one unique block, then this fact is indicated by the pyramid-like structure you can see in this small depiction. Yeah, information mapping can take advantage and can actively use primary visual variables and secondary visual variables. Of course, the difference is primary visual variables are stronger. So they are stronger with respect to the human perception and cognition, and of course to the information processing by the human user. Software maps also define always a map theme. A map theme is a concrete combination, or is expressed by a concrete combination of primary map data and optionally secondary map data that portrays specific aspects of software development and software engineering issues. Concrete combinations of map data are organized by software map templates. That is, in a visual software analytics setting, in a tool suite, for example, typically you find predefined themes, and each theme is specified by a concrete combination of certain software quality measures or data about repositories that report on developer activities, on editing frequency, on other aspects that are relevant for the specific theme. This combination, however, is called map theme. And think of a catalog where you can choose different themes. You can this way get insights into different aspects of your software system, and these aspects typically correspond to a certain assumption or theory, for example, about complexity hotspots. In the first example, we had this software map. Here's the example theme, implementation complexity hotspot, as a typical way to specify the combination of software metrics. Information mapping also relies on interactive elements. The interaction with software maps is essential for the quality of this tool, of this visual analytics tool. For example, we can get more information, we can inquire information once we click on specific cuboids, and in this case we get the concrete measured values as well as the difference, the progress, the trends behind by comparing the current version of the software system with the previous version of the software system. It's also given a definition or examples taken from the concrete modules here from the selected cuboid to get a better and direct hint about the reasons for these measurements. Yeah, so software maps are interactive interfaces to software analytics information and results. For example, the user can query the information artifact's name and all associated thematic values, as well as details such as normal value ranges if defined. This helps users to better understand these measured values. Let's summarize this part. We have seen software maps that interactively visualize software analytics information, such as source code, software quality, software dynamics and tests, software evolution, and all other related development processes by means of 2.5-dimensional tree maps. We also have introduced the concept of software map theme, which represents a concrete combination of software analytics information sources and their visual mapping to primary and secondary visual variables. For different aspects in software development and software engineering, corresponding different themes for software maps are typically used. Yeah, software maps aim at supporting different stakeholders in software engineering, in data-driven decision making and finding actionable insights. So this is the true objective behind software maps. If you have a theme, a software map theme, typically you can also derive in a data-driven way certain insights which lead to certain decisions, or at least the decision support, and you will find insights that are actionable. That means that can be put into practice. At least this is a quality goal of a software map. Yeah, in summary, software maps serve as a key and fundamental tool for visual analytics within the field of software analytics. Yeah, this concludes this part about software maps. We have introduced some terminology. The software map, defined by a visual mapping of a hierarchy of software artifacts together with related information about source codes, software quality, software dynamics, software evolution, and software development processes to a 2.5-dimensional tree map. We have also introduced the concept of primary and secondary visual variables. For software maps, the information can be mapped to the primary visual variables, that is the ground base, height and color, as well as to the secondary visual variables, the textures or shape variations. We have also introduced the software map theme, a concrete combination of software analytics information sources and their mapping to primary and secondary visual variables that portrays always a specific aspect of software development and software engineering issues. As further reading, I can recommend this article from Johannes Bonnet and myself, Monitoring Code Quality and Development Activity by Software Map, which may be a good description about how software maps are practically used in software engineering tasks. Yeah, let me end with a few personal remarks. Software maps provide a unique and general purpose interactive interface to software analytics, to all data that is relevant for software analytic tasks. The underlying 2.5-dimensional tree map allows for mapping at least 2 or even more information dimensions onto the hierarchy of software system artifacts. So this is a very understandable, comprehensible approach, mapping 2, sometimes 3 information dimensions, better 2 because you only have 2 free primary visual variables apart from the ground size of cuboids. It's color and height of cuboids, the 2 that are free. But it's a very easy to understand tool and mapping approach. So this is one of the core advantages of software maps. Yeah, in particular, software maps allow us to explore expected and to uncover unexpected correlations and phenomena between information dimensions in a straightforward way. Software maps can be cartographically enhanced by using secondary visual variables to provide a higher level of detailed information in the depicted map. This might be useful if you have an expert view of software data. You typically want to add more information, for example, difference information related to different versions of a software system. Yeah, a number of useful combinations have already emerged. That is, there is a catalog of software map themes which simplifies the practical application of software maps in software development and software engineering. Of course, these typical combinations have to be explored further, and this will be subject of other parts about software map use cases. We will, in these parts, explore different combinations and their practical application to an example software system.